Hello everyone. Thanks for watching this video. So this is a project overview video for our project called a knowledge graph warehouse for neighborhood information. So we are one of the theme one projects of this Proto-OKN program funded by NSF. So we have a cross-disciplinary, cross-institution team working on this project. And then we have project partner from National Institute of Justice. So let me first introduce our team members working on this project. So my name is Jing Gao. I'm associate professor at Purdue University. So I'm in the Elmore Family School of Electrical and Computer Engineering. My research interest is mainly in data and information analysis, focusing on data mining. My recent research focus is on natural language processing, AI trustworthiness and efficiency, and knowledge graphs. So I will let other team members introduce themselves.
Hello everyone. This is Jingbo Shang. I'm associate professor from UC San Diego, and I'm working on computer science and data science. My research mainly focus on large language model, weak supervision, and information extraction.
Hi, everyone. My name is Dan Semenza. I'm an associate professor at Rutgers University, and I'm also the director of research at the New Jersey Gun Violence Research Center, which is at the School of Public Health at Rutgers. Most of my research focuses on gun violence prevention and intervention.
Feng Long is not here today, so I will introduce him. So Feng Long Ma, so he is associate professor with College of Information Sciences and Technology at Penn State University. So his research interests are in data mining, machine learning, and health informatics. So his recent focus is on multimodal learning, medical foundation model, and AI security. Okay, so next I will pass to Dan to introduce the motivation and background.
Sure, thanks, Jing. So the core motivation behind this project is to fill a major gap in data need. Right now, most of the research and data that we have on firearm incidents in the United States focuses on homicide. So when somebody is shot and killed, or suicide when somebody takes their own life with a firearm. Unfortunately, we don't have a systematic way of tracking and providing data on non-fatal shooting incidents when somebody uses a gun against somebody else and shoots them, but that person does not die. And so firearm injury is the number one leading cause of death for people who are ages 1 through 17. It has been also a major issue throughout the COVID pandemic. And although shootings and homicides have gone down in the last couple of years, rates are still way higher in the US than most other peer industrialized countries. And so a big motivation for this project was to bring together different agencies that need this kind of information about where shootings are happening, how often they're happening, at a much more local level, not just understanding the big number across the entire United States, but getting an understanding down to the neighborhood and street level of where, when, how, and why non-fatal shootings are happening. And so there's a lot of limitations to the current research. Most existing data is really aggregated. Maybe you get it at the county, city, or police agency level, but it doesn't go further down than that. And really what police agencies and hospitals need is a lot more granular data. Incident level data, where shootings are happening in neighborhoods, are often housed in silos by individual police agencies. So the Newark Police Agency, Chicago Police Agency, and Tampa Police Agency all might know how many shootings are happening, but agencies don't speak to one another. And if you're a researcher or a practitioner, that data can be really hard to come by. So there's very little means of comparing across incident type, especially if you're trying to understand what drives homicides, for instance, versus non-fatal shootings. But still, the core here is that there remains no official source of non-fatal firearm injury data across the country. It is too siloed, it's too spread out. And so a key goal here was to start to bring that together across cities and ideally at a much higher level down the road. And I'll pass it back now.
Thanks, Dan. So basically motivated by this, so in this project, we propose to leverage open source police data, starting in some selected cities first, but basically the goal is to basically extend to other cities. And then we will collect incident level firearm shooting event information, and then integrate that with local neighborhood information. So for local neighborhood information, there could be different sources, but one source is the census reports. So we can collect that where the American Community Survey. So basically we integrate these different sources and then build a knowledge graph warehouse that help user easily navigate both aggregate and incident level firearm injuries and detect important patterns. So here is the overview of the whole project. So we will introduce more details in our other video on technical overview. But here I will just briefly mention the components in this project. So our project centers around the data structure called Knowledge Graph Warehouse. So the idea is to organize, integrate information from different sources and then organize information in this knowledge graph structure. And then these knowledge graphs are further organized by this warehouse data structure, which basically span different granularities in location and time. And then centering around this data structure, we have several themes. So we will have several components working on the construction of knowledge graph warehouse. So basically study how to turn our data into this data structure. And then the second part is like after we construct this data structure, then how to utilize it for insight extraction. So we develop some modules that help users, like develop modules that help users navigate information. And then the third theme is on the maintaining of this knowledge graph warehouse. So basically, in this part, we'll work on incremental updates, efficient querying, standardization. And then the end goal is to have both the data and the software available. I will pass again to Dan to talk about the data sources we use for this project.
So like Jing said, a big part of this initiative is to bring disparate data sources together. Like I said, we don't have one singular source of non-fatal shooting data. And so the goal is to start with 6 police departments that provide this data in a kind of open way that we could utilize relatively easily to get a proof of concept going. And so the core part of our data set is both fatal and non-fatal shootings. So we have comparison down to the incident level, to the street level, exactly where they're happening across 6 different police departments: Dallas, Atlanta, Cincinnati, Chicago, Philadelphia, and New York. And these data come from the Police Data Initiative, which is an open source way of getting at data across agencies. Then the goal is to pair these different data sources with, like Jing said, the American Community Survey, which includes lots of different demographic information about the neighborhoods where shootings are happening, down to the census tract, and in some cases, we'll be integrating street level data as well. That's everything from poverty rate in the neighborhood to unemployment, racial composition, percentage of those who say that they're socially isolated, and the percentage of disengaged youth not working or in school. We'll also be pairing with another database that includes a few other types of data resources, from city planning databases, from business address databases, to get a better sense of the context of where shootings are happening. So that includes land use data, residential, commercial, public, and industrial land use, information about the physical environment where shootings are happening, to get an understanding of kind of the risk of where those shootings might take place and patterning. That includes everything from local businesses to parks to green space, and housing projects that are around in the neighborhoods where the shootings are occurring. And then finally, integrating trauma center data to understand differences between fatal and non-fatal shootings, depending on healthcare resources, particularly trauma centers, at both level 1 and level 2. And we're getting that data from the American College of Surgeons. So all of this will be brought and integrated together to have this higher level, more integrated sense of information on these shootings across these 6 cities.
Thanks, Dan. So next we'll talk about our the progress so far on this project. So we started with the city of Philadelphia as a pilot study. So for this city, so we have used public data about the shooting victims in the city. And then we collected data set from OpenPhilly that include information about the shooting incident information, including the location and time, and also some information about the victims in that shooting. And then we integrate this data with the census data that we collect. And then the first thing we did is basically conduct this integration by aligning the location of the shooting to the census group so that we can pair together these two data sources. So here is a snapshot of the data that we have. So all the beginning of these attributes, so these are attributes from the shooting data. And then we have this latitude and longitude attributes. So basically, based on this information, then we can map to the census tract, census block, and then find the corresponding demographics information in that neighborhood. And then after that, we conduct this entity and the relationship extraction to form knowledge graph. So here is just a brief overview of the knowledge graph ontology that we have. So basically centering around this shooting incident as our main entity, we have other entities that cover some attributes about the shooting victims, and then as well as the location and then the time of the shooting incident. And then based on the location information, we can further track down to the census information. And then on the right-hand side, so this is just a snapshot of our knowledge graph. So the blue nodes indicates the shooting incident, and then the green nodes are the attributes that link to this particular shooting incident. And then we also design an interface that help users easily navigate the information out of the integrated data. So on the interface, we implemented several functionalities. So the first is definitely visualization. So we use several visualization tools to better present our data. So for example, so we map the data onto, display the data on the map, and then present a heat map based on the shooting events. And then we also visualize the incidents based on the year, and then display the counts with respect to the two major categories, so fatal shootings versus non-fatal shootings. And then we can zoom in, zoom out on the map. And then once we go to the fine-grained location, so users can click on an incident, and then that will present detailed information about the incident. So information about the shooting victim, and then whether it's fatal or non-fatal, and then some census tract information. And then on the map, users can select different areas, and then based on the areas users choose, we can conduct this aggregation and display information about the aggregated information. And then we provide some user interface where user can input further query, so they can choose the years they are interested in, some other information they want to filter based upon. So for example, some demographics information about the shooting victim, and then the type of wounds, and then whether it's fatal or non-fatal. So user can choose these, make different choices, and then we can display corresponding data. And then another interesting functionality that we have is basically the integration of this chatbot and map display. So we actually implemented these two-way interactions between map display and chatbot. So this interface demonstrates these two categories. So we have on the left-hand side, we have this natural language query interface, where users can input their query and get a text summary. And then on the right-hand side, we have the corresponding map display. And then the way it works is user can input some queries that they are interested in on the left-hand side. And then the system works by showing both summaries. So we'll demonstrate, present a text summary based on the user query, and then the data selection, data summary. And then correspondingly, on the right-hand side, the map will display the corresponding areas that users are interested in. And then on the other hand, the users can work on the map display. So they can input those selections, those choices. They can click on the areas they are interested in. So basically, they can do a variety of selections on the map. And then once they click this generate summary, and then on the left-hand side, this natural language queries will summarize the information based on the areas users selected. Okay, so I just want to mention that more information about the underlying knowledge graphs and then this interface functionalities, please refer to our other video on technical overview. So in that video, we will introduce these components in more detail and also what underlying techniques we use for the implementation. So next, I will pass back to Dan to talk about the impacts of this project.
Sure. So we see a number of different impacts, and a lot of that is going to be determined by feedback that we get from people who would benefit the most from using this. And so a part of this project is making sure that we are dialoguing with researchers, practitioners, people who are in hospitals and police agencies that would actually use this data to understand patterns and use it in a way that would be helpful to them in their day-to-day life for prevention and intervention. So one of the major impacts here is establishing a novel data infrastructure, creating a knowledge graph warehouse for firearms data, and building a kind of new paradigm for organizing this information that has multiple sources, multiple levels across the ecology to get a more comprehensive understanding of a problem that has a lot more light being shown onto it, but still requires a lot more data to back it up. And so we see this as one step towards building a better data infrastructure for the issue of gun violence in the United States. We also think that this also helps to improve accessibility when it comes to firearms data. Although there are more and more public sources that are becoming available for people to be able to look at, oftentimes the resources are not updated, the data isn't consistent, or it's not put into a format that is searchable and easily used and reusable and up to date at multiple levels of the ecology, meaning you can't necessarily get information at the city level all the way down to the block or the neighborhood. And so this is also not just about creating the infrastructure, but making it more accessible to people who need to use this kind of data. And to that point, empowering local communities. It enables a more neighborhood level analysis that goes deeper down than just the entire police agency that might cover a city, to get into the context of when, where, why, and how shootings happen. And so this is certainly to help aid police agencies, but also community violence groups, hospitals and healthcare centers, social services, anyone who is involved in gun violence prevention and intervention as a whole. This is designed to be a tool to help in that ecology. And finally, the goal is to make this a foundation for interdisciplinary research. Gun violence prevention requires an all hands on deck approach, meaning that we need people from lots of different disciplines and practices to provide their insight. And so the goal is to establish a sustainable national data source and infrastructure that can evolve as more data comes available, and then be expanded to other domains of injury surveillance or public safety analytics as this continues to mature.
Okay, thanks, Dan. I think that's all for our presentation. For more information, please refer to our project website, where you can find more detailed description about the project. And then we have a prototype website on this website, and then you can try out our prototype. And then thanks again for watching this video. Please check out our other video on the technical overview. Thank you.